So Mike here, it's a little update on the refrigeration test bench. It's definitely up and running. This is the Mark II. The first one was the belt-driven system that was pretty damn crude. So just to briefly go over this, I did a little video yesterday where I chilled some beer down. But it's still rather crude, but it's a hell of a lot better than the first version. What we have is a 2 1/4 horsepower treadmill motor. Driving a 10-inch pulley with my mid-drive system here. It's a wooden flywheel. And then from the mid-drive, we have a small 1 3/4 inch pulley. It goes up to the 6-inch pulley on the York 210 compressor. The compressor has a clutch out of a 86 Volkswagen. You know, my interest here, my reason for doing this, building this thing, is to test out some ideas that I have for refrigeration, just get some hands-on, and do a little DIY, you know. I could have easily ripped apart a air conditioner or dehumidifier and pulled a perfectly good hermetic compressor out. Been quiet running, relatively efficient, but I thought this would be a little more fun. And plus I can vary the speed on this thing. So I have a tack here, little sensor, pickup coil. There's a magnet that spins around on this thing here. Where you at, magnet? There you are. So that seems to work pretty well. This thing here is a 10.3 cubic inch displacement. There's 2 pistons. This thing's a little loud. I'm going to run it here in a minute. It squeaks and squeals and knocks. And I have a few other compressors here. This one's actually a 1998, but it needs cleaned out. And the head plate, the valve plate, valve cover plate needs to be switched out. But I need to get a gasket kit before I can get into that. So we have a discharge here into a 1/4 inch line, temperature sensor here, and then it runs up into this condensing unit here. It's just coiled simply inside there. It's about 20 feet or something. I have it written down somewhere how much copper is in there, and then there's a cooling water tubing that pumps water up through it, counter current. So the cold water's rising as the heat is actually being discharged and the refrigerant is condensing and coming out the bottom. I just have an aquarium pump in this bucket over here, and that's just a little feature of it, a little diverter that sprinkles a little water, maybe evaporates a little bit of the water, discharge the heat. And we have a liquid line sight glass, filter dryer, service valve into the receiver, and then the discharge on the receiver, another service valve, rotor lock, should be picking up nothing but liquid off the bottom, discharges, temperature sensor. This is just a 1/4 inch needle valve. It seems to work fairly well for my purposes. That's my throttle. I have this little screwdriver attached to it to give me a little more control on it because it's pretty sensitive. Very minute little alterations, little changes to it really drastically changes the suction pressure. And my shitty brazing here into a 3/8 line, and then this goes into the evaporator. Now this is another liquid line moisture indicator sight glass. I could have just put a union in here, but I thought, hey, it'd be kind of fun, shits and giggles and all, to actually see the quality of the refrigerant going through, the rate of it going through. There's some pulsation that you see because I'm running this thing at such a low speed. Today I was running at about 80 RPM for the most part. So you see a hell of a lot of pulsation in that liquid line sight glass there. And you also see some pulsation in this too. The refrigerant surges and then falls back and surges and falls back. And you can play with it a little bit and put some heat to the bottom of it with the palm of my hand and watch it bubble. And then from there it goes down into this 3/8 coil, which this is about 20 feet long as well. You can see it's all froze up down here at the bottom. I just drained the water out so it's easier to see. But yesterday I did about this much, made about this much ice in probably 15 or 20 minutes, and chilled some beer down. I was running at a much higher speed. Today I wanted to run at low speed and play around with it. Now, pretty much once it got to this point, and this probably took a half an hour, 40 minutes maybe, from starting water temperature of 50 degrees Fahrenheit, about 10 quarts of water in there. That once it got to that point, it was pretty well done freezing. And I think the compressor and then the whole system was just keeping up by absorbing heat from the condensation on the pot, since this thing isn't insulated at all. You know, I know I'm going to have to use an insulated vessel if I want to do any calorimetry at all to figure out how much heat's actually being pulled out of the evaporator. But just for now, this is just, again, just for shits and giggles, playing around. Yeah, anyway, suction line, another temperature sensor back into the compressor. I bought this crappy little thing on eBay, and you get what you pay for, because it's basically worthless. The associated temperatures with the pressures I'm operating at, it's nowhere close. And even though I'm using barbecue grade propane for this system, and the temperature pressure charts that I'm referring to may not exactly be accurate, they seem to more closely correspond to what I'm actually seeing in the operation of the machine than this thing displays. Yesterday I just had them, the thermistors just taped on to the lines, and I thought, well, maybe I need some insulation, so I just hacked some insulation up that I had laying around and wrapped around it, and it really didn't make much of a difference. You know, the high side will be 10 degrees lower than what it probably truly is. The low side, it'll display 35 degrees Fahrenheit right here out of the throttling valve, when it's obviously freezing, well below freezing. I mean, it's frosting over quick. I can drip water on this line here and just watch it freeze. So it's very, very, very cold. And the corresponding temperatures that I'm, operating at might be 15 degrees Fahrenheit. I've had it down to probably around 0 degrees Fahrenheit. It gets damn cold. But the corresponding suction pressures that I'm ending up with, at least the superheat values, are pretty high. And again, this thing is about worthless as far as telling me. But to be perfectly honest, I actually used the infrared thermometer, and it seems to more closely correspond to the actual reasonable temperature than this damn thing does with direct contact. So I'm gonna have to get a better system, probably something with logging, maybe something I can calibrate. This is pretty much see what you get, and that's about it. I guess I might as well just fire it up and play around with it a little bit. Like I said, it is loud, and it's unfortunate that it's so loud. So I'm going to have to address those issues. Give it a second to kick on. Engage your clutch. You can hear that squeaking already. Now, I don't know if that's a characteristic of these compressors in general, or if get it loaded the compressors there, or if it's just this particular compressor. It's a little wore out. After a period of time, it'll start knocking a little bit, and it's only once a revolution. And since there are two pistons and they're 180 degrees out of phase, I think there's a problem with one of them. The squeaking, I'm not exactly sure what the squeaking is. If it is piston rings, and maybe just running at this extremely low speed, it's not getting proper lubrication and it's just wearing itself out. It's things I'll find out. So I'm going to ease her back down. It's kind of funny to have a refrigeration system running at this low speed, but it's interesting. That's pretty good right there. So, we got our water running on the condenser, probably somewhere around 75 or 80 degrees Fahrenheit. And then our low side, let's see, about 47 psi is probably somewhere around, right around freezing. have to check my chart. It's on my phone, so I gotta get that stuff printed out. Don't know. Oh, there you can see it a little bit. There's a bubble a little more. We add a little heat to it. If we open her up, I can actually hear it in the receiver there. So, if we open up the throttling valve, you'll see the suction pressure rise. And the temperature of the evaporator will start to rise as well. Ice is starting to melt pretty fast. So, if we crank her down, we can actually get it down to the point where we essentially stop it. And it is just working on boiling what liquid remains in the evaporator. And the pressure on the low side will begin to drop. Basically nothing in there. So I'm going to go ahead and crack it just a little bit, or else it'll pull itself all the way down to a vacuum. It's very sensitive. Yep, there we get a little bit. Get the heat off my hand there. About 44 pounds per square inch on the suction. When I run this thing a lot faster, say upwards of 200 RPM, which isn't very fast by most people's standards, it starts producing a hell of a lot of heat. This water is just not quite lukewarm right now after running for an hour or so. So anyway, she's starting to freeze up again. So, it's loud, it shakes, it squeals, it's still kind of a turd, but I know what I have to do. Oh, something else I did today. Now, I'm taking high side pressure directly off of the head of the compressor, and out of curiosity, I wanted to know how much pressure drop there is through my condenser and through this filter here. So I threw this sucker in line. It's tapped off of the service valve here. Now it's a different gauge, different manufacturer, so I don't know how well they correspond with one another, but showed about 150 pounds on this one. And although it jumps quite a bit, probably 155 to 160 on that. So I mean, I've seen that across varying ranges of pressures. It's about 10 psi drop across this sucker here. You know, it's small lines, and 20 feet of that stuff in there. So I figured that was going to have some problems with pressure drop, but I will address that with a distributor or something in the future. I'm going to go ahead and shut her down. The speed jumps a little bit. So, as far as what I need to do to improve this machine, like I said, I need to get some gaskets. This one, I did clean this compressor out yesterday. I tore it down and cleaned it relatively well, but I didn't take the gaskets off. They ripped a little bit, didn't know how well it was going to seal back up, and filled it up with mineral oil. I don't know where I put it. Anyway, bought it at Wally World. About one bottle of this will do. One compressor. Takes about 14 ounces. So what I need to do is to clean this sucker up here, get some new gaskets for it, probably take it through the parts washer at work, and see if that doesn't squeak as much. Maybe it has a little better performance. I don't know, but I'm going to find out. Now, beyond that, my condenser here, it leaks a little bit. These caps are just pushed on. I didn't put any glue or anything in there, so I might have to deal with that because it drips a little bit. Not the end of the world though. And a major thing is I want to build a new evaporator. Starting this project, I wanted to build a flooded type evaporator rather than a dry type like this. So essentially, the first one I build, I've been changing the design a lot lately. But I think I'm going to probably take this coil itself and I'm going to put a sort of a header on it. Okay, so I'm going to have a piece of 1-inch pipe. See if I have anything to demonstrate with. We'll use that. So, might be on the outside of this coil rather than on the inside like I'm demonstrating now, but a piece of vertical pipe and the line coming directly off the throttle will actually go into that pipe. And then off of that pipe there will be the line which right now is connected directly to the throttle, and then the suction going back to the compressor is also going to be attached directly to this pipe. And the liquid level will be maintained at such a point that it corresponds very closely towards the top coil of the entire evaporator. And what that allows me to do is to keep the entire inside contents of the inside walls of the evaporator coil wet at all times. So there'll be a lot more refrigerant in the system, and any bubbles that are produced any vapor that's produced, especially the flash gas coming off of right after the throttle, can be sucked off and taken directly back to the compressor rather than have to travel through the entire length of the tubing. Now ideally, I would have a number of shorter coils that would be attached to that common 1-inch pipe, that common header. And the reason being, as bubbles are produced, as vapor is produced through the ebullition boiling process, those bubbles can get out of the evaporator because they're not doing any good at that point. They're only going to pick up superheat, which is going to lower the vapor density and hurt volumetric efficiency and create more work that the compressor has to do. But for now, I think I'm just going to go with the one coil. I suppose I could split this one down into two and just have them kind of lobed side by side with the common pipe in the middle. I might do something like that. I'm not sure yet. Wouldn't be that much more difficult. And in order to regulate the amount of refrigerant in there, I'm probably still going to use the needle valve or a flow control valve. It's just another style that's probably very similar to this in internal construction. And I'm going to use a sight glass, just like this one, probably will be this one right here. And it's going to simply have a line that comes off the top of that header. And I don't know why I call it a header, because it's not really a header, it's on the side, but it kind of serves the same purpose. It's a common volume to the rest of the system. And it stores excess refrigerant. But anyway, I'm going to have a line that comes off the top, goes down, goes back in, and I have that sight glass in the middle of that line. So it'll just be like a sight glass you would be measuring, on a tank or something like this, where you would just have a tube of glass. Well, instead I'm just going to have that little sucker there, and then I'll just maintain the liquid level somewhere. As long as I can see the line there, I know that I'm regulating it fairly well. And if it's more or less constant load, then I shouldn't have to fiddle with the throttle too much. So that's the main interest of mine. And I'm going to have to put it inside of an insulated vessel with a window of some sort so I can actually monitor refrigerant level. Yeah, other than that, might be doing some insulating on my lines, even my discharge line off my compressor, because eventually I'd like to insulate my condenser and insulate my cooling tank and measure the volume of water that's actually within that system, and measure the starting temperature and the stopping temperature the same way that I'll measure the starting and stopping temperature of a known volume of water, or antifreeze. I'll probably be using propylene glycol mixture in here, so I don't have to freeze the coils up directly, because that's just stupid. and that allow me to along with getting a better temperature monitoring system, to try to model the system better and to figure out how much heat I'm moving. I'm going to do some work with monitoring the amount of electrical consumption of the motor, but I don't care that much about how much electrical power it's using. It will be of note, but that is inefficient. And if I can collect enough useful data on the rest of the actual vapor compression and mechanical side of things, I can figure out how much actual mechanical work is being done by the compressor. And yeah, I might compare that to how much electrical power input there is, but it's really of little consequence to me. So yeah, that's just a little update on the refrigeration test bench, belt-driven compressor. Yeah, if you like it, cool. Comment or whatever.